Okay Ella, just a really quick video, knocked up in a couple of minutes. Haber process uses nitrogen and hydrogen to make ammonia. It's really important, makes all sorts of important chemicals like fertilizers. The process is ever so easy. The nitrogen and the hydrogen have got to react quickly, so we use a high temperature, 450 degrees centigrade. We use a catalyst to speed it up, and we could use pressure, but we don't, because that would mean specialised equipment that costs too much. So we leave it at atmospheric temperature and pressure. Sorry, atmospheric pressure. The forward reaction, remember we did my favourite chemist, Le Chatelier. That one is exothermic, so heat is given out. So that heat is going to be given out during the reaction. That's quite useful actually, because we can use that heat that's given out to provide some of this heat here that's going to speed it up. So all you've got to remember, the forward reaction is exothermic, and my mate Le Chatelier. If we have a look at the best conditions that we could use, these are the best conditions, and I've left the equation in the middle. Le Chatelier says whatever you do to the reaction, it's going to move forwards or backwards to try and overcome, minimise that change. So in theory, if I was to pressurise the reaction, there's 1, 2, 3, 4 particles on this side and only 2 on that side. It should move forward. So it would be really good to use a high pressure. But we don't, because it costs too much to make the specialised equipment. So we leave atmospheric pressure, and all that happens is we don't make quite as much ammonia as we could do if we had used a higher pressure. Remember, forward reaction is exothermic, it gives out heat. If we heat it up, we're going to give these particles lots of energy, they'll bang together more quickly and they'll react faster. Problem is, high temperature would mean the reaction moved backwards and not as much ammonia would be formed. Industrialists don't want to wait ages for their product, so they compromise. They use a high temperature to get smaller amounts of product more quickly. So the catalyst speeds it up, the high temperature speeds it up. We do that to make an optimal product to get as much yield in a reasonable amount of time as possible. I've summarised those bits there. There's one other thing we can do. As the ammonia is produced, we can take it away. The Chatelier says whatever you do, the reaction will try and overcome it. So if we take our ammonia away, more of the nitrogen and hydrogen will combine to replace it. And we can keep a continuous process going by putting nitrogen and hydrogen in, taking the ammonia away as soon as it forms. Just having a look through that should help you with what's important about the Haber process. There's also my PowerPoint. I hope that helps. See you Monday.